Today we will start on inverse hyperbolic function. Yesterday we learned the inverse trigonometric functions. We learned how to find sine inverse, cos inverse, tan inverse, cot inverse. And we said that we have to restrict the domain to find the inverse because the original trigonometric function are not one-to-one function. So you have to restrict the domain. For example, here sine is not one-to-one. We have to restrict the domain, then we can find the inverse. Similar for cosine, similar for tan, cotan, and cosine, cosec, and secant function. And then we said that these identities are not always true. We need to be sure that the result within the range of your original function. For example, here cos inverse x not always equal to x. You need to be sure that x within the range of cos. So you need to be sure that x within -1 and 1. And similar for the other's identity. Then we prove some basic relation. We prove that sine inverse plus cos inverse is always equal to pi over 2. Hopefully all of you try to, a similar way, prove that tan inverse plus cot inverse is equal to pi over 2. Similar, sec inverse plus cosec inverse is equal to pi over 2. How to find sec inverse? It is equal to cos inverse 1 over x. Cosec inverse is equal to sine inverse 1 over x. Cot inverse is equal to tan inverse 1 over x. So here, for example, sine inverse 3 is undefined because 3 is not within the range of sine. For this one, sine inverse sine 135 is not equal to 135. It is not within the range of sine inverse. You need to find a value located within the range of sine inverse. When you find a value for a positive value, take your angle from the first quadrant for sine inverse. If you calculate sine inverse for negative value, take your value from last quadrant. Similar for tan inverse. Tan inverse for a positive value from first quadrant, tan inverse for negative value from last quadrant. Cos inverse for positive value from first quadrant, but cos inverse for negative value from second quadrant. Here we calculate sine inverse sine 225. It was a negative value. So sine inverse for a negative value should be angle from the last quadrant. And then we prove some other relation. For example, cos sine inverse x is equal to root 1 minus x squared. So we have to, assume that theta is equal to sine inverse x. Then we find the cos theta by using the triangle with right angle. Here we prove that sine inverse minus x is equal to minus sine inverse x based on the identity that sine is an odd function and sine minus theta is equal to minus sine theta. Sine minus sine theta is equal to sine minus theta. And the last example that we have this relation and we need to find the value of x that make this relation true. That makes this relation true. So we assume that 2a plus b is equal, assume a is equal to sine inverse x, b sine inverse 2x. So 2a plus b is pi over. From here, a equal to sine inverse x means that sine a equal to x, b sine inverse 2x, which means that sine b is equal to x. Sine, you have sine b is equal to 2 sine a. Multiply both sides by cos a to get this relation. Now using the triangle, because you can draw a triangle for this relation and another triangle for this relation. The triangle for sine a equal to x, you can find cos a. The triangle for sine b equal to 2x, you can find sine 2a because 2a plus b is equal to pi over 2. If this one is equal to b, this angle is equal to a. So you get this equation. This equation only have one variable x. If you solve this quadratic equation, you get two values of x. This one we have to reject because x is greater than 1. So sine a cannot be equal to x here. because x greater than 1. So you have to reject this value and accept only the negative part. Today we'll start by similar way in inverse hyperbolic function. Inverse hyperbolic function. If x is equal to sine y, then y is equal to sine inverse x. If x is cos y, y is equal to cos inverse x. If x is tanh y, y is equal to tanh inverse x. We need to find these functions. Sine inverse, cos inverse, and tanh inverse. If you look for the function sine inverse x, the original one, if you remember the graph of the original one, it was one-to-one function. The original graph of sine x, it was one-to-one function. This was like that. This was the graph of sine x. So this graph is one-to-one on its domain. On a real number, it is one-to-one, so you have no problem for sine x. You just find the inverse. So here, the domain for sine inverse of x have no problem, no need to restrict. Domain no need to restrict because already sine x is one-to-one on its domain. So just reflect the graph over the line y equal to x. So the domain is still a real number. And the range also a real number. You have no issue here. No need to restrict the domain for sine because the original one is already one-to-one function. What about cos x? What about cos x? Should we restrict the domain for cos x or not? Should we restrict the domain for cos x? Did you remember the cos x? This is the function. If you didn't remember the graph, it was the graph for cos x like that. This is the graph of cos x. This graph, I told you, is not one-to-one on its domain. On all real number, it is not one-to-one. So you have to restrict the domain of cos. You need to take the positive one only. So this is the value. So if I take only the positive one as a domain, this domain will become your range here. And the range here for the original one, the range was starting from 1 to infinity. 1 cos 0 is equal to 1. So the range was from 1 to infinity will become your domain. So your domain will be for cos inverse, will be from 1 to infinity. This is the domain. And then you need to reflect only this bar around the line y equal to x. Only this part you have to reflect around the y equal to x. So if this is the line y equal to x, so should be your graph like this. This is the graph of y equal to x around the line y equal to x. So this is the graph of cos inverse x. Here for sine, no need to restrict the domain. The function already one-to-one. But here for cos, you have to restrict the domain because the original function not one-to-one. It is one-to-one if I take only the positive part. So this is the positive part will become your range. And your range from 1 to infinity will become your domain. So this is the graph of cos inverse x. What about tanh? Tanh x, if you remember the original function was like that. We here 1 minus 1. We have a horizontal asymptote at 1 and minus 1. Sorry. So this is the graph of tanh x. If you remember, this is the graph of tanh x. Now, tanh x was one-to-one function on its domain. Tanh x was one-to-one function on its domain. So, tanh x, no need to restrict because it's already one-to-one, so no need to restrict. So the domain here, which was all real number, will become your range. No need to restrict any domain. So already the function is one-to-one. And the range here, which was between -1 and 1, but not include the point -1 and the point 1, all the numbers between -1 and 1, this is your range, will become your domain. Here will become your domain. So your domain will be from -1 and 1. -1 and 1, and then reflect the graph around the line y equal to x to get this graph. So this is the graph when we reflect around the line y equal to x. So what we did is similar to what we did when we find the inverse of trigonometric function. Before finding the inverse, we need to be sure that your function is one-to-one. For sine and tanh, the function is one-to-one. So we can find the inverse directly. Only for cosh, the function is not one-to-one, but we need to restrict the domain to make it one-to-one. When you restrict the domain, take only the positive part. So the positive part is from 0 to infinity. This part is 1-to-1. You can reflect around the line y equal to x to get the graph of cosh x. Get the graph of cosh x. Any question? Okay, if you don't have any question, now we need to know how we can find cosh inverse x, how we can find tanh inverse x, how I can find sech inverse x. Did we have a formula for cosh inverse x? We have a formula for tanh inverse x. Can we find a formula? So we have a formula for a 6 inverse trigonometric function. Cosh inverse of x is equal to the natural logarithm x plus root x squared minus 1. While sine inverse x is equal to natural logarithm x plus the root x squared plus 1. The formula how we calculate, this is the definition of tanh inverse x, cosh inverse x, sine inverse x. These are the definitions. We have a definition for cosh, sine, and tanh based on exponential function. Definition of sine, cosh, tanh was based on the exponential function. But so the inverse for sure will be based on the natural logarithm, not on exponential. The tanh inverse is 1 over 2 natural logarithm 1 over x plus 1 plus x over 1 minus x. Inverse x is equal to 1 over 2 natural logarithm x plus 1 over x minus 1. Similar for sec inverse and cosec inverse x. These are two formulas based on natural logarithm. No need to memorize this formula. These formulas all will be given to you in the exam. Here what we need to know how to prove this formula. How we can show that cosh inverse x is equal to the natural logarithm x plus root x squared minus 1. Root x squared minus 1. As we learned before, if you remember, we learned how to find the inverse of any function or the formula for the inverse. You need to go for the formula, for the original formula for the original function and replace each x by y and each y by x. Replace, and this is what we did. Here I will prove for you the first one. Cosh inverse x is equal to this. We will prove this one. We will try to prove that cosh inverse x is equal to the natural logarithm for this one. So here, this is your original function. Y is called cosh x. This is your original function. And this one you need to, and this one is equal also exponential x plus exponential minus x over 2. Now to find an inverse, Similar for any function. First step, replace each y by x, each x by y. First step, you have to replace each y by x, each x by y. So this is what I will do to get the inverse. Here y will be replaced by x, and x will be replaced by y. So you will get that x is equal to cos y, and which is equal to exponential y plus exponential minus y over 2. This one. Now we try to solve this one for y. We need to find y. So from this relation, 2x is equal to exponential y plus exponential minus y. I need to solve this equation. Exponential y plus exponential minus y. Okay, what do you think? How we can solve this one? I need to find y equal to what? What I am trying to do now is we need to solve this equation for y. Y equal to what? So what I can do here? We have x. First step, we replace each y by x and which x by y. This is how we can get the inverse of any function. If you remember, when we find the inverse of any function, after we replace the domain and range, get the formula, go for the original formula, replace each y by x, each x by y, and try to solve for y. Try to solve for y. We need y equal to what? So I have this equation, 2x comes from here. 2x is equal to exponential y plus exponential minus y. So what do you think? How we can deal with this equation? We can do. Any idea, any suggestion how we can find y? What I can do here? I have 2x is equal to exponential y plus exponential minus y. Yes, no, we have to multiply by exponential y. We have to multiply both sides by exponential y. These sides, you have to multiply by exponential y. 2x exponential y, 2x exponential y will be equal exponential 2y, exponential y times exponential y is exponential y squared, plus exponential minus y times exponential y, exponential 0, exponential 0, which is 1, which is 1. If you just make rearrangement and transfer this one to the other side, so it becomes the positive here will become negative. So you have exponential y squared minus 2x exponential y plus 1 equal to 0. After you multiply and make rearrangement, you get this equation. First term, multiply exponential y by exponential y, so exponential y squared. Now plus exponential minus y, exponential y, exponential 0 plus 1, this term. 2x exponential y is 2x exponential y. Transfer it to the next side to become negative. So we have all the terms in this side, so this side should be equal to 0. Should be equal to 0. So exponential y squared minus 2x exponential y plus 1 equal to 0. Now this is a quadratic equation. We will use the quadratic formula to solve this formula. Minus b plus minus b squared root of b squared minus 4ac 2a. Here a is equal 1. This example, a is equal to 1. B is equal. B here equal to minus 2x because I'm solving for exponential y. I'm solving for exponential y. A is the factor of exponential y squared, which is equal to 1. B is the factor for exponential y, which is equal to minus 2x. B is minus 2x, and C is equal to 1. C is equal to 1. Now applying this one, exponential y minus b, which is minus 2x is equal to x plus negative. Is the root of b square. B square here is 4x squared. 4x squared. We have minus 2x squared, which is 4x squared. Minus 4ac. 4 times a times c. So minus 4 times 1 is minus 4 over 2. Over 2. So we have here 2 with 2 will cancel each other with the 2 from here also. Because we have 4 from the root is equal to 2. So 2 and 2 and 2 will cancel each other. So you will get only x plus or minus root x squared minus 1. But since exponential y, the exponential function always greater than 1, you have to reject the negative 1. You have to reject the negative 1 because exponential always greater than 0. This is the exponential. I need y, not exponential y, so take the natural logarithm. So y is equal to natural logarithm x plus root of x squared minus 1. This is formula. This formula. Now we need to find the inverse of y cos x. So again, to find the formula for the inverse function, go for the original function and replace each y by x and each x by y. Then try to solve the equation for y. Okay, my original formula for cos is y equal to cos x exponential x plus exponential minus x over 2. This is the definition of cos. From the definition, you need to replace each y by x, each x by y. So you have exponential y plus exponential minus y over 2. Now try to solve this one for y. This one is equal to x plus 2x is equal to exponential y plus exponential minus y. So multiply all the equation by e to the power y, ey. So you get that 2x ey is equal ey squared plus minus y times ey minus y plus y 0, exponential 0, which is 1. So exponential y squared plus 1 minus, when you transfer to the next side, minus 2x exponential y. This is a quadratic equation. To solve for exponential y, you need to apply this formula, quadratic formula. Here for quadratic formula, a is equal to 1, b is equal to minus 2x, c is equal to 1. Applying this formula here, these values in this formula, you get that exponential y is equal to x plus or minus x squared minus 1. Reject the negative 1 because exponential y should be greater than this part, should be positive, not negative. So you take only this part. So y is equal to the natural logarithm. Exponential y is equal to this value. So take the natural logarithm for both sides to get the value of y. Y will be equal to the natural logarithm x plus root x squared minus. Any question? If you have any question, you can open your mic or you can write on chat. Okay, that's good. By similar way for sine inverse x. Same way exactly. Prove that sine inverse x is natural logarithm x plus root x squared plus by similar way exactly. So I will prove also sine inverse x for you, but at home you have to prove tangent inverse x and cos inverse x as well. Others. By same way. For sine inverse x, need to prove that sine equal x is equal to the natural logarithm x plus root x squared plus 1. Okay, first step, what we have to do. First step, what we have to do. You can write on chat or open the mic. Now we can find or prove that sine inverse x, or find the formula for sine inverse x, and show it is equal to the natural logarithm x plus x squared, the root of x squared plus 1. Same as I did here. Same as I did here, I will do for sine. I will do for, so what is the first step? What is the first step to find the sine inverse x? To find the formula for the inverse of any function, first step you have to do what? Change x to y. Yes. Change x to y. This is y sine x. Y we have equal to sine x. This is the function that we need to find the inverse. This is the function that I need to find its inverse. This function is equal to x, should be equal to exponential x function is equal from definition to exponential x minus exponential minus x over 2 from definition. Now first step, change x to y and y to x. Y will be replaced by x. X will be replaced by y. Exponential y minus exponential minus y over 2. X replace y by x, x by y. Then you get that 2x is equal to exponential y minus exponential minus y, this equation. Now multiply with exponential y. Multiply with exponential y. You multiply by exponential y, you get that 2x exponential y is equal to exponential 2y minus 1. 2x exponential y is equal to exponential y squared, or exponential 2y, minus exponential minus y times exponential y is equal to 1. Rearrange this equation, you have exponential y squared minus 2x exponential y minus 1 equal to 0. This is a quadratic equation. You need to apply the quadratic formula to find exponential y. By applying the quadratic formula, you get two values for exponential y, x plus or minus x squared plus the root of x squared plus 1. Again, you have to reject the negative part, because exponential y should be a value greater than 0. So this is why you have to reject negative part. Exponential y is equal to x plus root x squared plus 1. Need y, not exponential y, so you have to take natural logarithm for both sides. So y will be equal to x, natural logarithm x plus x squared plus 1. Now, in the exam, you'll be given, all these formula will be given to you. No need to memorize, but you need to know how to prove. So please at home try to find tangent inverse x, or need try to prove. Tangent inverse x is equal to 1 over 2 natural logarithm 1 plus x over 1 minus x. Also try the other three. Cos inverse, sec inverse, cosec inverse. Now using definitions. Here, you need to evaluate using definition. Using definition. You need to use definition to find sine inverse 0.5. Sine inverse 0.5. So sine inverse 0.5 is equal to sine inverse 0.5 is equal to using definitions means this formula. Using definitions means this formula. These are the definitions. These are the definition of inverse hyperbolic function. So I will use this formula. I will use this formula. X plus root of x squared plus 1. is equal to by using definition, it is equal to the natural logarithm x, which is 0.5 plus 0.5 square plus 1 by using definition. Using definition means you have to use this formula. Natural logarithm x plus root of x squared plus 1. So here natural logarithm 0.5 plus 0.5 square plus 1. Can you find the value? And you find this value is equal to what? 0.4. Okay. Thank you, Sophie. 0.4 812. All failed 1. Now cosh inverse similar. Cosh inverse minus 2. Sorry, 0.5. Try to calculate cosh inverse 0.5 using definition. Using definition, all of you try to calculate cosh inverse 0.5. Using definition of cosh, this one. The definition of cosh inverse. Natural logarithm x plus root x squared minus 1. Use this one, find cosh inverse 0.5. And then write the answer on chat or open the mic, give me the answer. Cosh inverse 0.5. You get math error, math error, math error, math error. Why? Why you get math error? You know why we get math? You got math error? You know that why we get math error for cosh inverse 0.5. Yes, and yes. Cosh inverse should be, if you go again for cosh inverse, be careful about the domain and range. Cosh inverse only for the values greater than 1. For the values, the domain starting from 1. No values for cosh inverse 0.5, cosh inverse 0.3. No values. The values should be starting. You can find the cosh inverse for 1, cosh inverse for 5, cosh inverse for 10. But for sure, you cannot find any cosh inverse for 0.5 or any value less than 1. Your domain starting from 1. But be careful about the domain and range of the functions. The exam, we didn't ask you what is the domain of tangent inverse or what is the range of cosh inverse. We give you like these examples. Then you need to be careful. You need to say why it is not undefined. So cosh inverse here is undefined. Can't find cosh inverse for 0.5 because x should be greater than 1. X should be greater than 1, not less, not less. Okay, but you can find cosh inverse 1.5. Try to find cosh inverse 1.5. Wash inverse 1.5 by using definition. Wash inverse 1.5 by using definition. You will get a value because 1.5 here, this one is greater than 1. So no, should be no problem. So you have ln 1.5 plus the root 1.5 square. I think minus 1 or plus 1. I think minus 1. Minus 1. Minus 1. So your friend give us the answer 0.962. 0.962. 624. Okay, tan inverse minus 0.6. Try to find tan inverse minus 0.6 using definition. Tan inverse minus 0.6. I will show you now the definition of tan. We need to find tan inverse for minus 0.6. This is the definition of tan inverse. We need to prove this definition. This is the definition of tan inverse. Use this definition and find tan inverse for minus 0.6. Tan inverse for minus 0.6 and give me the answer. And then give me the answer. Why error? No error here. For minus 0.6 should be no error here because within the range. This is the definition of tan inverse. For minus 0.6. We need to find tan inverse for minus 0.6. No error here. Minus 0.6 is within the, because tan inverse is between minus 1 and 1. So minus 0.6 here is already here. You have to get a value. No error here. Find tan inverse to minus 0.6. Who can give me the answer? Yes, minus 0.6931. Minus 0.6. Yes, good. Okay. 1 over 2. I will apply this formula. 1 over 2. This one will be equal to 1 over 2 natural logarithm x plus 1 plus x, which is 1 plus x, which is minus 0.6 over 1 minus x over 1 minus x. We can write better. We'll write the formula first and then we can. This is the formula of tan inverse x. Okay, so I will replace x. I will replace x by minus 0.6. It is equal to 1 over 2 natural logarithm. 1 plus x is 1 minus 0.6. Here, plus x is minus 1.6. 1 minus x, which is minus 1.6. Minus here and minus here. So it be 1 over 2 natural logarithm 0.4 over 1.6. 1 plus 0.6. Now if you try to find the value of this, I think it should be equal as your friend calculator is equal to minus 0.6931. I think the one who get math error have a problem here in the sign. Maybe you have problem on the sign, minus 0.6. You didn't make it minus, I guess. But you should have, and because minus 0.6 is within the range from minus 1 and 1. If I ask you to find tangent inverse for minus 1.6, then you get math error because minus 1.6 is outside your domain. So yes, in this case, you can get math error, but 0.6 is within your domain, so for tangent inverse. So it should be no problem. Any question? Any question? Okay. Solve the equations. As we usually did, we have some examples that we need to show or prove. Some example, we need to find the value of x. We need to find the value of x. In the exam, you have to differentiate between these type of two questions. Okay? We need here to find the value of x that give you sine inverse x is equal to natural logarithm of 2. Sine inverse x is equal to natural logarithm of 2 using definition. Here, when I told you using definition, you have two options of the solutions. Okay, you have two options for the solution. I will solve this part A by two methods, and two methods are correct. When I ask you use definition to find sine inverse x is equal to natural logarithm of 2, you have two options of the solution, and both are correct. First, you can use the definition of sine inverse x because sine inverse x is, by using definition, is equal to the natural logarithm of x plus x square plus 1, x square plus 1, which will be equal to natural logarithm of 2. So sine inverse x by using definition is equal to natural logarithm x plus root x square plus 1, and this one we make it equal to natural logarithm of 2. So I will solve this equation for x. By taking the exponential of both sides, you get that x plus the root x square plus 1 equal to x plus x square plus 1 is equal to. So now just take the square of both sides because I have a root here. So the square of both sides, I will solve this equation for x. X plus root x plus 1 square is equal 4 by taking the square of both sides. And be careful here, or maybe we can make it more easier, because here when you take the square, you have a plus here. You cannot distribute the square. So I think easier for you to do like that. You solve, maybe you can go for it. Before you square, just make that x square plus 1 is equal to minus x. If you continue as I did just now, is okay also. But here, so this one is easier. Now take the square. So x squared plus 1 will be equal to minus x squared. 2 minus x squared. X plus 1 square will be 2 minus x squared. So this one, x squared plus 1 will be equal to 2 minus x squared, first part square, last part square. I have a negative sign here, so we keep the negative. 2 times 2 times x, which is 4x. 4x. Be careful, this is not equal to 4 plus x squared only. This is not equal to 4 plus x squared or 4 minus x squared. If you multiply 2 minus x by 2 minus x, it is equal to 4 plus x squared minus 2 times 2 times x, which is minus 4x. Because this is a common mistake between students. Now solve this equation. Now x squared from here can be cancelled with x squared from here. And then you get that 4x will be equal to 3. So x is 3 over 4. 3 over 4. This is the first solution. This is the first solution. This is the first solution. First solution, what I did is I used the definition of sine inverse x. I use the definition of sine inverse x because I need to solve this one using definition. So that what is the definition of sine inverse x? It is equal to the natural logarithm x plus root of x squared plus 1. This one is equal to natural logarithm of 2. Now solve this equation for x. First, ln with ln will be cancel each other if you take the exponential for both sides. If you take the exponential for both sides. So you get this equation on x only. You can square both sides from here, but maybe the calculation more difficult. So it is easier to bring the x here. So the root of x squared plus 1 will be equal to 2 minus x. Now square both sides. You get x squared plus 1 is equal to minus x squared. 2 minus x squared, if you try to multiply 2 minus x by 2 minus x, you get 4 plus x squared minus 4x. Cancel x squared with x squared from here. So you have 4x is equal to 4 minus 1, which is 3. So x is equal to 3 over 4. Any question for the first solution? Any question for the first solution?
So far, so good.
Okay, nice. Now this one, P. Sorry, before B, I will solve. I will make another solution before going to B. Second solution, I will use the definition, but not the definition of sine inverse. I will use the definition of sine. Because I have the equation is like this. Sine inverse x is equal to natural logarithm of 2. I need to solve this one. So instead of going for sine inverse, you can go for sine, because from this equation, you can say that sine, if you take sine for both sides, will be equal to sine ln 2. Ln 2. If you take the sine for both sides, so sine inverse x will be equal to sine to ln 2. Take sine of both sides. So x, because sine inverse will cancel each other. So x will be sine ln 2. Sine ln 2. Using the definition of sine, x is equal exponential ln 2 minus exponential minus ln 2 over 2. Over 2. Using the definition of sine, not the definition of sine inverse. So x exponential with ln here will cancel each other. You have 2. You cannot cancel because you have a negative part. Here we have a negative, you cannot cancel directly because we get a negative here. So you cannot cancel directly. You have to transfer the negative as a power first. Transfer the negative as the power first. So exponential ln 2 to the power minus 1 is 1 over 2. Over 2. So 2 minus 1 over 2, because exponential with natural logarithm, exponential with ln function will cancel each other. Over 2. If you calculate this value, you will get equal to 3 over 4. It is equal to 3 over 4. Same answer like this one. So for these questions, if we usually ask you use definition to find this one. So it's up to you. If you use the definition of sine inverse x or the definition of sine. If you use the definition of sine inverse x, you go for the formula for sine inverse x. As a solution, you take sine for both sides. So sine inverse will cancel each other. So you will get x is equal to sine ln 2. And this one, you can use the definition of sine. Definition of sine exponential x with exponential ln 2 minus exponential minus x, which is exponential minus ln 2 over 2. Calculate this one. Exponential with natural logarithm can be cancelled. Here I cannot cancel because I have negative part. I have a negative part here, we couldn't cancel. So we have exponential ln 1 2 to the power minus 1 is same 1 over 2. 2 to the power minus 1 is same 1 over 2. So now exponential with natural logarithm will be cancelled. So 2 minus 1 over 2 over 2. Calculate this one is 3 over 4. So either you use this solution or this solution. Both are correct, both are acceptable. So it is up to you. Which one you feel easier for you, you can use. Now, second example. If you don't have any question for the first example, you will go for the second example and the last example for this chapter. Solve for x. Cosh inverse 5x is equal to sine inverse 4x. Cosh inverse 5x is equal to sine inverse 4x. This is P. I need to solve this equation for x. I need to solve this equation for x. Cosh inverse 5x is equal to sine inverse 4x. Okay. We think what we can do. Cosh inverse 5x is equal to sine inverse 4x. Okay, I will give you the first step. I will help you in the first step. Let A equal to cosh inverse x equal to sine inverse 4x. We will assume that because both are equal, cosh inverse 5x is equal to sine inverse 4x. Both are equal. So we need to know, I will make both equal to A. So what we understand that A is equal to cosh inverse x equal to sine inverse x. Sine inverse 4x. Sorry, 5x. This one is 5x. Cosh inverse 5x. cosh inverse 5x. Okay, cosh inverse 5x is equal to sine inverse 4x. Let A is equal to cosh inverse 5x equal to sine inverse 4x. Okay, what we can understand from this one, what you can conclude. And I said that A is equal to cosh inverse 5x equal to sine inverse 4x. What you can conclude, this means what? A equal to cosh 5 and cosh inverse 5x. First start for the first relation. A is equal to cosh inverse 5x. This means what? Cosh A is equal to 5x. Yes, correct. This means that cosh A is equal to 5x. Okay, what we mean that A is equal also to sine inverse 4x. Sine inverse 4x. This means what? This means what? The second relation. Yes, sine A is equal to 4x. We have that cosh A is equal to 5x, sine A is equal to 4x. I need to use these two information to find an equation for x that I can solve and find the value of x. How we can do this? How I can use cosh A, sine A to find equation for x. We need to find the equation for x. We have that cosh A is equal to 5x, sine A is equal to 4x. So I need to use these two information to try to find a value or equation that include x that I can solve to get the value of x. Which identity I have to use? Which identity that I have to use? Cosh square A minus sine square A equal to 1. Yes. Cosh square A is 1. Cosh square A minus sine. We have this identity is always true. Cosh square A minus sine square A is equal to 1. Is equal to 1. So just substitute. Cosh square A, which is 5x squared, minus 4x squared is equal to 1. Is equal to 1. Now I will solve this equation. 5x squared, which means that 25x squared minus 16x squared is equal to 1. Is equal to 1. 25x squared minus 16x squared is 9x squared. Equal to 1. Equal to 1. So here, you have that 9x squared equal to 1, which means that x squared is 1 over 9. Take the root, so x will be equal plus or minus 1 over 3. Plus or minus 1 over 3. So again, what I did is just, we have that cosh inverse x, this equation. we need to solve this equation and find the value of x that satisfies this equation. So assume A is equal to cosh inverse 5x equal to sine inverse 4x, because these two values are equal. So just assume these two values are equal to A. What we can conclude? We can conclude that cosh A is equal to 5x, sine A is equal to 4x. How I can use these two information to find equations that include A? Use this identity. Cosh square A minus sine square A always equal to 1. So you have 5x squared minus 4x squared is equal to 1. So 25x squared, when I square here, minus 4x squared, which is 16x squared, is equal to 1. So 9x, 25 minus 16 is 9. So 9x squared is equal to 1. So x squared 1 over 9. So x plus or minus 1 over 3. Question? Any question?
Doctor.
Okay, since you don't have any question, I have a question for you. X is equal plus or minus 1 over 3. Should we accept both or not? Should you accept both or not? Should we accept the positive value and negative value, or we have to reject one?
Reject one.
Which one?
The negative. Because the range is above 0.
Range for which function?
For cosh function.
For cosh inverse x. Yes, for cosh inverse x, this one, this value should be greater than 1. Here, maybe if you go for cosh, this value should be greater than 1. The range here, or it should be greater than 1. So if you take the negative part, this one will undefined. Cosh A will not be equal to negative value. Cosh not be equal to a negative value. Cosh always greater than 1. So it cannot be a negative value. So you have to reject x minus 1 over 3. So usually in the exam, when you get 2 or 3 solution, you need to be sure that all solution should be acceptable. So this is only value that satisfies the equation. So this is your solution. This one should be rejected. This one should be not accepted. Will not ask you in the exam directly about what is the cosh inverse, what is the sine inverse, and so on. What is the domain and the range of cosh inverse, sine inverse. But you need to know, because some solution you get, some values you get for x should be rejected, because it is not within the range and the domain of the functions. So you need to be careful. Any question? Because by this example, we end chapter 2. By this example, this is the last example. So by this one, we end chapter 2. This is the last example on chapter 2. So if you don't have any question,